A warm welcome to our 7th module in the series Special Quadrilaterals. Today we are going to explore interesting set of quadrilaterals called kites. After this module, you will be able to identify the special quadrilateral, a kite, analyze its properties and apply them to find the missing values. But before we take flight, let us quickly answer a few questions. Which of these is not a characteristic of a quadrilateral? It is a closed two-dimensional shape. It is made up of 4 straight line segments. All its sides and angles are equal. The sum of all its angle is 360 degrees. You may pause the video to match your learning pace. Exactly, quadrilateral is a closed two-dimensional shape made up of 4 straight line segments. This definition aligns with that of a polygon, with the only difference that this polygon is made up of 4 line segments, as the name suggests, quadrilateral. As far as the angles are concerned, be it interior, be it exterior, all add up to 360 degrees. So the sum of interior angles is 360 degrees and sum of all exterior angles also is 360 degrees. So we are left with the third option. All its sides and angles are equal. Not for all quadrilaterals. Only for certain special quadrilaterals, all the sides and angles are equal. This is exactly what we are going to dig into through our future modules. As of now, we'll go ahead with this option, which is not a characteristic of a quadrilateral. Moving on, one more concept that is essential for us to understand before we dig into the quadrilaterals is parallel and intersecting lines. Identify the incorrect statement. Parallel lines lie in the same plane and never meet. Intersecting lines lie in a plane and cross each other. A transversal intersects 2 or more lines at a single point. Pause the video and choose the correct option. Indeed, parallel lines lie in the same plane and they never meet or cross each other, no matter how far they are extended. Intersecting lines also lie in the same plane, but they do cross each other or meet at a single point of intersection. Whereas a transversal is a line that intersects the parallel or the intersecting lines, but it crosses them at distinct points. For example, if it is crossing 2 parallel lines, it will cross them at 2 separate points, not at a single point. Same holds true for non-parallel lines. So the third option is incorrect. Let's observe this quadrilateral closely and answer these 2 questions. See how we've taken a line AB and created its exact copy CD. As we move these 2 lines without changing their alignment, you will see that the distance between them never changes and they never meet. They may overlap, but they will not cross each other. Similarly, if you observe the other set of lines, BC and AD, what's your observation? Follow the grid in the backdrop. What do you observe? These lines may overlap, but they will never cross or meet. So what kind of lines created this quadrilateral? Parallel lines, absolutely right. And how many pairs of parallel sides does this quadrilateral have? 2 pairs. Exactly. But do all the quadrilaterals have 2 pairs of parallel lines? Let's explore the special quadrilateral. So, before we begin classifying quadrilaterals, let us quickly recap what quadrilaterals are. They are closed 2D shapes drawn using 4 line segments. So, all the polygons that we are going to discuss from this point onwards will have 4 sides. We will explore their angles, their sides and diagonals. So, on the basis of number of parallel sides, we will now classify quadrilaterals. Some quadrilaterals may have 2 sets of parallel lines. That means both the pairs are parallel. Others may have 1 set of parallel lines. And then there might be quadrilaterals which will have no set of parallel lines. On the basis of this, we can name these quadrilaterals. If a quadrilateral has 2 sets of parallel lines, they are called parallelograms. You can observe the image, see how these arrows are depicting the opposite sides which are parallel to each other, and this quadrilateral is called a parallelogram. Then there are those quadrilaterals which only have 1 set of parallel lines, and it is quite evident from their appearance. You can see that this special quadrilateral has only one set of parallel lines. The other two sides will definitely intersect when extended. They are a very common sighting and they are called trapeziums. Followed by those quadrilaterals which have no set of parallel lines. They indeed are unique and special in their own ways, and they are called kites. You can observe the difference in the appearance of the three special quadrilaterals. Observe the special quadrilateral ABCD on the screen. Notice how the sides AB and CD are not parallel to each other. They will intersect when extended. And what can you say about the sides AD and BC? They too are not parallel. Such special quadrilaterals which have no set of parallel sides are called kites. If you observe their shape closely, you will realize how well known this shape is to you. Now that we are exploring the special quadrilateral kites, let us relate it to the kites that we all have seen. Some of us may have flown it or even created the kite frame. So how is a kite frame created? We take a vertical stick that is called the spine and take another support stick called the spar and place it crosswise, creating a pivot point at 90 degrees, which is slightly above the center of gravity. This gives the optimal flight to the kite. So if you examine this kite structure, you will realize that there are two shorter sides and two longer sides which appear to be equal. As discussed in our previous module, to understand any quadrilateral, we have to have a command on the three essential components: the sides, the angles and diagonals. As of now, the only information we have that kites are special quadrilaterals with no parallel sides. Let us explore more. So we've taken a stick or a thread and divided it into two unequal parts. So we'll create a copy of it. One over here you can see is 9.3, other is 12.2. So we are going to create a copy of it and then open it up, creating a kite. So this is a unique feature of kite that the adjacent sides, can you see the adjacent sides? AB and AD, the shorter ones, they are equal. Similarly, the longer sides BC and CD, they are also equal. This one unique feature is the defining characteristic of kite. No parallel sides, unlike other quadrilaterals, and also adjacent sides are equal. So this is one takeaway for kites. Their adjacent sides are equal. So using this information, can you now define kites? Can you write your definition? Starting from the basic that a kite is a quadrilateral with two pairs of adjacent sides equal. Can you identify the adjacent sides which are equal? The shorter ones AB and BC are equal. The longer ones AD and CD are equal. And do pull in the concept we have done previously, that none of its sides are parallel. So this defines kites completely. So let us put this information in our graphic organizer, which we will complete by the end of the module. We will do the same thing with other quadrilaterals also. So for the sides, apart from that they are non-parallel, adjacent sides are equal. See, a quadrilateral will either have adjacent sides or opposite sides. In most of them, the opposite sides are equal. In some of them, all are equal. But this is one special quadrilateral where the adjacent sides are equal. So what impact will it have on angles? Let us observe. Let us see if they have any angle pair equal. Observe this kite on the screen. See the orange color angles. They are equal. Then we have pink and blue. They are not equal. So one thing is sure, that equal angle pairs are getting formed. But where are they getting formed? That is one important aspect of kites. So first of all, let us note this fact down, that this quadrilateral has exactly one pair of opposite angles equal. But if you can observe closely, you will see that there are two sides which are equal, the shorter and the longer ones. And these equal angles are getting formed at exactly between the unequal sides. Let us see further. If you observe, the equal angles are angle K and angle T, right? And where are they getting formed? They are getting formed at the point of intersection of equal sides and unequal sides. EK and KI are not equal. So let us complete our graphic organizer, in which we have already fed our details about the adjacent sides. So what will you talk about angles? Again, angles can either be opposite or they are going to be adjacent. So are the opposite angles equal or adjacent? Opposite angles are equal. And which opposite angles? The ones that are getting formed where unequal sides meet. So now we are only left with the third component before we become expert in kites. So let us explore the diagonals. While discussing the kite frame, we had already discussed the pivot point. So these the two sticks, the vertical stick and the support stick, the spine and the spar, they are crossing each other at 90 degrees. So what actually is happening? The spine actually divides the support stick, that is the spar, into two equal parts. Longer stick is not getting divided, the spine is not getting divided, but actually the shorter one, that means AC, will bisect BD. The longer diagonal is going to bisect the shorter diagonal. Let's understand it. So over here, can you observe? AC is the spine, the vertical stick, and it is dividing the spar, that is the shorter stick, into two equal parts. And I have told you previously, we've discussed also, for a better flight. Though the spar can be curved and other shapes also, but traditionally this is for a better support 90 degrees. So both the diagonals intersect at right angles, but only one diagonal is getting bisected or getting divided into two equal parts. So let us apply this concept that now you know that BD is going to cut AC into two equal parts. So how will you apply it? Can you answer this question? Kite ABCD is shown and the shorter diagonal is 44. So when it is cut by the longer diagonal, so what will be half of it? EC will be, applying the rule, the longer diagonals bisect the shorter ones. So over here AC is going to be half of 44, that is it's going to be 22 centimeter. This is one objective type question that can be asked of you. So let's note down the points of diagonals. The key takeaway is that the longer diagonal bisects the shorter one and they intersect at right angles. So no wonder that this special quadrilateral is aptly named kite, because of its resemblance with the actual kite that we all fly. So now let's complete our graphic organizer, which already has our information about the adjacent sides. Whenever you talk about kites, talk about adjacent sides, talk about opposite angles. So what about the adjacent sides? They are equal. And what about the opposite angles? They are equal, but the ones that are getting formed at the unequal sides. And the diagonals, they bisect, but not both. The longer one cuts the shorter one into two equal parts, and also when they cross each other, they make a 90-degree angle. Now you are all set to answer a few questions. In a kite, just one pair of opposite angles are equal. Is it true? Correct. One pair of opposite angles that are getting formed where the unequal sides are joining or meeting. In a kite, the diagonals are perpendicular. What do you think? Yes, the diagonals are perpendicular. The longer diagonal is bisecting the shorter one also. So if you have a good command right now and you are feeling confident with the concept, don't go through the entire video later on, but do visit at least for all the modules, do visit the questions and keep practicing them so that you don't forget. In a kite, both the diagonals bisect each other. So you know the answer, not both, but only the shorter one is getting bisected. Bisect means getting divided into two equal parts. Now the last one, in a kite, equal angles are formed between the unequal sides. Absolutely right. This statement is correct. Now you will join me in the next video to uncover another special quadrilateral, trapezium and parallelogram, and until then keep learning, keep practicing and stay curious.
Stay in the video till the end to dive into the rapid fire round and show off your math skills. I'm now leaving you with questions that will challenge your understanding. Put your pen to paper, music on or mute, whatever helps you focus. Take your time and let your math progress shine and reflect.